This is ICP-10. Here our main objective is to do extractive summarization and abstractive summarization using different models and then with different data set and compare those quality. Here we have done extractive summarization with one model which is ExcelNet and abstractive summarization with another model which is T5 large model from the BERT. Here you can see we have taken data from the Reddit app. I've taken these links from the Reddit and took the data which is in the form of comments and used that data. This code is used to extract those comments and use it in my data. This is extractive text summarization. Here as I've said earlier, I've used ExcelNet model. With the ExcelNet model, I've done my extractive summarization for the previous Reddit data I have collected. And then I've got my summary in this format. See, I've got my summary. And then for abstractive summarization, as I said, I've used T5 large model. For abstractive summarization, I've taken a random article and then used that to summarize for summarization. And then when I used my T5 large model, it gave me the summary as. So this is our main objective and this ICP. This is ICP-11. Here, our main objective is to use another data source from Twitter or Reddit API, and then use another base model for the evaluation, and then compare those two. So here I have taken my data from the Reddit again as well. So I've taken the same Reddit data which I've taken in ICP-10 and then used it here for my extracting topics and then for topic representation, and then I've used that for topic modeling here with this. Then I've extracted topics. You can see, and then these are attributes, and then I've visualized my topics. So you can see different formats of visualization, how I've visualized my topics. This is topic probability distribution. This is topic hierarchy. This is topic scores. How many? I mean the use of words in each topic. This is topic similarity matrix. So this is again one of the topic similarity matrix. This is team score per deadline per topic. Then you can see here the topic updates, and this is topic reduction. If there is unwanted data, we can reduce the topics. This is for switching topics. And then and we come to embedding models. Here I've used the XML Arbor based STB mean tokens as my model. And then for sentence transformation, I've used NQ Distilbot based V1 for our embedding models, and then sentence modeling. So this is my embedding model, and then this is my sentence modeling. With this, I've done my sentence transformations. So here, the challenges I faced is like cleansing the data. It took more bit of task for gathering data and cleansing it, for using it in for the sentence transformation, and then embedding for topic modeling. So here for all the comments that I've taken previously, or the comment data that I've taken previously from the Reddit, here you can see from this, we have got the topics. You can see those in the visualization as well. You can see these are the topics that we have got. This is something like related to games. This is something like monitors, something. This is something about paints. There's something about vehicles, cars, something. So these are the different topics that we can see from the comments. So this is about the ICP-11. Here we have achieved all the objectives. So we have used different source, and then we have used different model for both sentence transformations and then topic modeling. And then when we compared this with the previous LDA technique, we have achieved bit good of results. Here our topics are more clear, more understanding, and then sentences as well. Uh, uh, Keywords are more preserved. We can find the sentences more accurate when compared to LDA technique. This is all about our ICP 11. This is our ICP 12. Here our main objective is fine-tuning the model with another data set, and then increasing the number of samples used, and then generate the report with the different parameters. So here I've used the uh, another data set. Here I've used the Amazon reviews multi data set from the Hugging Face, from and then I've got my data set, which is like review ID, product ID. This is my labels in the data set. And then I've used it. So you can see a glimpse of data here. Then this is review. You can see the graphical representation of data. And then here we have tokenizer. Here we have used this GP2 tokenizer instead of TF-IDF tokenizers, which we have here, or BERT tokenizers, which we have previously used in the previous ICPs. But here we are using GP2 tokenizer. And then we have tokenized, and then we have got some sample text instances. This is token embedding. This is all about our dataset preservation, dataset loaders, and then fine tuning our model. So I've configured my model, and then I've used CUDA as CPU, and then I fine tuned my model. And then, as I said previously, one of our main objective is performance metrics, report generation with different performance metrics. Here, as such, here we have used top K sampling and then top P sampling. So here you can see this is my code for the training, and then getting the generating the report with different samples. Here I can show you something like top K sampling, top P sampling, do sample. So I've used all these parameters for my report generation. So you can see sample outputs, model generate. So these are the metrics I've used my report generation. So these are, it took, I've used 5 approaches, and in each approach I got my result as such. With the average training loss of 0.2, and then each approach took around 7 hours for I mean more than 7.5 minutes, and then my validation loss is like 0.22. You can see the validation took time, and then here it took around 7 hours, 7 minutes 39 seconds. Here it took 7 minutes 40 seconds. You can see these are the approaches, and then my sample output. So here it's summary of training process it is. Here you can see my graphical representation of training and validation process. And this is my model info, which is like our GP2 model, which we have used. And then this is for saving our model to our Google Drive and then fine tuning it. Let's save it to my Google Drive. So this is generating text. I've saved it, and then I'm generating text here. You can see this is for model evaluation. So this is the sample output we have got. Again, after we did our model evaluation, this is the sample output of sentence, and then this is the generated top K sample max length top P. You can see this is the output we have got again. When we take this is the sample output. We have got again something like when we take a this sample output and use it here, we got this result, which is our text generated when we take those reviews from the Amazon multi data set and then get the output. This is ICP 13. Here our main objective is make use of validation set and then change the number of hidden features. This is an optional thing. I'm not able to do it here, but I was able to achieve good amount of results for the using of validation set and changing number of hidden features. This is the sample code given to me. Uh, mm, this is the sample code given to us. I've used the same data set, haven't changed the data set for this ICP. When as like in previous ICPs, if I remember for 10 and 11, I've used Reddit data, and then for 12, I've used Amazon reviews from the Hugging Face, and then for 13, I'm using the same data, but I'm using the validation set again, different validation set, and then I'm changing the hidden features parameters which was there in the model. So I've done my code for validation accuracy. So this is the code which is already given. So I've added my validation accuracy to the code, which is validation MLP here. Since here the model is MLP model, I've done my validation MLP. Then I've got my validation accuracy, validation accuracy, and then I've done my validation for CNN and then got my validation accuracy, as well as same I did for validation for GNN. You can see validation accuracy for MLP, validation accuracy for CNN. And then same we did for GNN. So let me show you. So this is my validation accuracy for GCN. I did my validation. So here, this is my validation accuracy for GCN. This is my model presentation for GCN. This is for MLP. And then this is GAT convolution model. So same as like GNN, CNN, and MLP. This is the GAT convolution model. And then this is my code for changing the hidden features. So previously in the given code to us, the hidden features. Let me just go for it once. So in the hidden features here, P is given 0.5 and the hidden channels is given 60, but I reuse the P as 0.5 and change the hidden channels to 8. You can see here, same 0.1, change the hidden channels to 8 and train my data, which is 8 data set. And then my training MLP, testing MLP, validating my MLP. So I've trained my CNN, test my CNN. Sorry. This is my validation CNN. And then I've got my output here. This is my validation accuracy for MLP, 0.57, validation accuracy for CNN, 0.5740. This is my model again. My validation for GCN, after we change the these validation accuracies I'm showing you is after I change the hidden features from 16 to 8. My validation for 0.811. My model evaluation after I change my hidden features. So this is optional, which was given in our objective. So I was not explaining the optional thing here, but still I've done my part of code, so I was not that accurate with the output here. So I've done my part of code for GAT convolution model, which is optional. But we did our main objectives here, which is make use of validation set. I've shown you the code for the validation set where I've used, which is for MLP, CNN, and GNN. We have done our validation accuracies for these three, and then changed the number of hidden features, and then did again validation for these three, which I've shown here. I've shown the validation accuracies which I've got for all the three. I can show one more time. This is validation accuracy for MLP, validation accuracy for CNN. Even after we change the hidden layers, we have got our validation accuracy. Validation accuracy for MLP, validation accuracy for CNN. Validation accuracy for GCN. After we change the hidden layers from 16 to 18. This is all we have done for our ICP 13. Thank you.